Right, welcome back my ninjas to another video. In this one we're going to be doing a lab just to get some hands-on practice with ether channels, and this is going to be section 2.4 if you're following along on those CCNA exam topics. This is all about configuring and verifying ether channels. So let's just get straight into it right now with what even is an ether channel. So like an official definition of it, if you want to define an ether channel, would be it's just a logical bundling of multiple physical channels. To elaborate on that or just break that down, what that means is if you have a physical cable and you connect to port 1 on one switch and you connect to port 1 on another switch, that's one connection. Then you could do port 2 on switch 1 again and port 2 on the next switch, so on and so forth. So now you have these two connections that the switch sees. It sees, hey, I got a connection up on port 1 on this switch and it's going to my neighbor switch 2 on the other switch and it's on this port and everything. What an ether channel allows you to do is configure it to where the switch says, oh, I only have one connection, even though you have multiple connections, even though you have ports 1, 2, 3, and 4 on the respective switches. The switch will be tricked, for lack of a better term. You tricking that switch into seeing just one logical physical connection. And to take that even a step further, right? Let's say that somebody cut one of those cables out of the bundle. Let's say it just broke. The switch is still going to view that port channel as up. It's not going to think that, it's not going to tell you that, hey, you lost or it's going to tell you that you lost that connection in the logs and everything. But as far as the port channel is concerned, that's still going to remain in an up and up status. When you go to look at the health of it and everything, you're still going to see a healthy port channel. It's just going to show you, hey, you lost one of your links in the bundle if you had 4 links in one bundle, because you can have up to 8 in a single port channel. Beyond that, there's many other reasons why you would want an ether channel, but the main reason, I believe, in my opinion, is that you're leveraging the bandwidth of your ports, because all these ports have speeds, right? So if you have a fast Ethernet port, we know that that's going for 100 meg speed on that port. Now, if I have 2 ports that are each 100 meg and I combine them as one port logically in the ether channel bundle, now that port, it has 200 meg instead of just 100 meg. And that can play an important role, especially like with STP, right? Because we know that STP does that port election and deals with those ports based on how much they cost, right? So if you got something that costs 100 meg, but now you got something that costs 200 meg, that's going to influence that cost. So instead of having a cost of 19, you're going to have a lower cost, which will influence a different root port election. Hopefully that makes sense. Let's go ahead and jump into this packet tracer lab so you can see these costs and everything and all of this stuff changing as we're configuring these ether channels and as we look at STP and everything, just to get a more in-depth kind of view of it. All right, so boom, we got that same packet tracer lab pulled up, right? And it's very basic just to install packet tracer and everything. If you need a video on how to install it, drop it in the comments, let me know. I could just do a quick video on that. But basically, just go ahead, download, install packet tracer, and then throw you up some switches. I got 2 2950 switches up here, and I got some 3550, because we're going to go over configuring ether channel for layer 2, which are these switches. And then we're also going to look at configuring it for layer 3 ether channel, because you're going to have to know how to do both for that CCNA exam, and you're going to have to verify both. But once you configure layer 2, all layer 3 is just throwing an IP address with it. So that's the only difference really, because we already know, or we should know, OSI model layer 2 and layer 3 are different, and layer 3 is definitely IP addressing and everything like that. So we got switch 1 over here on the upper left hand corner, we got switch 2, switch 3, switch 4. And as you see, we already got STP running by default, right? So this right here is showing that this port is blocked. It did the root port election and all of that. So we know this is the root port. We know this is the root switch. Same thing down here. It even did a root port election and everything. They blocked on this side. So this guy's the root switch. You feel me? Just go ahead and look at my STP video if you want to look about how all of that happened and if you want some more information on that. So let's jump into let's look at switch 1. Let's look at switch 2 where it's blocking and everything. Let's pull this up. So we're going to jump into switch 2, right? And let's look at show spanning tree. As you can see, we got the blocking port. What I want you to pay attention to is these costs here. You see 19, because we got 2 individual ports right now. Each of these ports, they are 100 megs, so that's why the cost is 19, and then this one's blocking, and that's because of STP and everything like that. All right, so the first step, if you want to configure an Ether channel, the best practice is to shut down all the ports. This is for lab, or even if you're in a production environment, just to avoid any kind of this is electronics, and this is software and everything. So to just avoid everything, let's shut down all the ports. You want to configure the Ether channels and then bring everything up, and then you can verify it like that. Instead of doing one switch, configuring everything while everything's up, the other switch, and then something might go error disabled or something like that. Something crazy might happen to you. So that's what we're going to do first. So first of all, we're going to go into conft interface range command we're going to use. Now we're going to FA01 and 2. So now we're going to run this config. That's all that interface range command is doing. We're running it on both of these ports, these commands that we're going to enter. And all you want to do is shut down on this one. And let's hop over to, since we're doing it on this one, we're going to shut down on this port, on this one too, on switch 1. All I'm doing is shutting them all down just so we can avoid any confusion. You don't have to do it like this. This is just best practice. I recommend doing it just so we don't run into any kind of issues, especially because we labbing up, we trying to learn. We don't want to, you feel me? We don't want to make it even more harder than what it already is. And we'll just stay here in switch 1 since we already here. So now that we got them shut down, we can start configuring our Ether channel. So you want to do channel dash group, and then you're going to have to, let's use some help right here with that question mark. This is your channel group number. You got channels 1 through 6 that you can configure. Now, the important thing to remember when you're configuring Ether channel, whatever you configure that Ether channel, it's got to be the same. You can't configure channel 1 here and then jump over to the other switch that you're configuring for Ether channel and configure that for channel 2. No, it's got to be the same. So since this is the first Ether channel, I'm going to just do 1, right? Then the next is going to be mode, and then you're going to have a list of options. These options right here, I highly suggest you memorize them. Again, I did some videos on memorization and everything. You need to know active, auto, desirable, passive, and on. You need to know all these different ones and how they relate to these different LACP and PAGP. So auto desirable is going to go for PAGP, auto and desirable, and then active and passive go for LACP. Use some kind of trick, some kind of memory tricks or whatever you got to know that active and passive, because they're going to try to trip you up on all these kind of questions on the exam. They're going to try to ask you stuff like, is auto part of LACP? No, because you be labbing, right? That auto is part of PAGP and desirable is part of PAGP. So what we're going to do, we're going to look at LACP specifically, and we're going to just configure this as active. So we're going to do active right here. Boom, and it's creating that port channel for you right there. That's the first port channel, so you're going to have to swing over to the other switch, and we're going to have to do that same thing on the other switch over here. So let's jump over to the other switch. Same thing, right? Channel dash group. Remember, we got to stay with that same group, mode, and then we're going to do active here. and there's nothing else to do, and it's creating that port channel there. Now let's go ahead and no shut these things, bring them up, and let's see what happens. No shut here, and then we're gonna want to swing over to the other side too, right? Over here, and we're gonna want to do no shut. Now, before we start verifying if the ether channel is up and everything, let's look at show span and tree. All right, let's look at this again, where we seen that it's blocking and all of that stuff when we ran that show span and tree command. Let's look at it now that we done configured this. Now let's look at what it's talking about after we no shut it in and created that port channel. Let's get out of that. Show spanning tree. Now look at that, boom. You only got one port, right? Instead of having those two. This is the root port over here. And look at that cost. That cost done dropped. I told you the cost is gonna drop because now, let's run it again because it should be, okay, now is completely converged, right? Now it's in the forwarding state instead of in the learning state right there. But what we want to look at is that cost has changed from 19 to now it's 12 because we done combined both of those fast Ethernet fast Ethernet ports into one port channel. That's one thing that I wanted to show you. So now you can verify your port channel many different ways. I really want to show you if you do show run, your port channels, whenever you configure port channels, they're going to come up first before even your physical stuff comes up. This logical port channel is going to come up first. So that's the first thing that I want to show you. Now, if you want to verify the ether channel, you can use show ether channel, right? You can use this command. And what's this command going to show you? It's going to show you what kind of ether channel you got. You got a layer 2 or layer 3. That's showing you that you got a layer 2. The max ports on this, you could put 16 ports in a bundle, and you're only using 2 ports right here for this port channel, and then the protocol LACP or PAGP, right? That's what you can get out of that information. So if you see that on the test, that's the command that they used. And then of course your channel group number is up here. Now if you take it a step further, you can just do a show ether channel summary. Gives you a little bit more detailed information, and definitely if you're on live equipment, there's going to be even more detailed information that you can get, right? But this one, I mainly use this even when I was working, and it's going to show you the ports that are bundled, and then it's going to show you the status, right? So P, that means that it's in the port channel. If it was down, it would have a D with it. Suspend, standalone, all of these. Layer 3 if it was a layer 3 port, right? And layer 2 for S for layer 2. So right here we see the S for layer 2, and then the U for in use as well, right? And then another command that I like to use as well is show ether channel, and then I believe it's, let's use some content, a port channel, port dash channel. The reason why I like this one is because it gives you that time that it came up 3 minutes ago, whether it came up an hour ago. So if you're troubleshooting, this is a good one to know, like, when did this port channel come up? When was it created? Because what if it lost its config and it just came up, and then you can start troubleshooting some other stuff. So that's why I like that command right there, because it's going to show you the last time or how long that this port channel has been up. So really that's mainly it for configuring the port channel. You've got those 3 commands to verify that show ether channel port channel. If you're using packet tracer, it's going to show you the uptime. Then this show ether channel summary is going to show you the port channel status and all of that kind of information. And you got show ether channel, which shows you layer 2. Another way you could verify it too is if you just look at the port channel. So if you do a show interface port channel 1, you see that hardware is ether channel. That's how you know that this port channel is up and is being recognized by the switch and everything. And look at the bandwidth on that boy. You feel me? I don't even know that number, 200,000 kilobits, which equals 200 meg right there. Instead of, and now if you have 4 of them in there, it would change that number to 4. Just play around with this stuff. Put them in that bundle, put more in that bundle, and push it to the max and see what you could see for that. So that takes care of layer 2 ether channel. Now we're going to do the same thing, but let's jump back over here to this topology. But instead of doing layer 2, and also check out this, there ain't no blocking with that STP. Everything is open. So let's look at one more thing here too really quick. So if we jump in here, I also wanted to show you this just to make sure it don't make a liar out of me, right? If we go conft interface FA 0/1 and we shut that boy. Let's shut that boy. Now let's still verify our ether channel. Is that thing still gonna be up? Port channel 1. Boom, that boy's still up. It's still showing up right there. Let's look at our ether channel commands that we just used. Show ether channel. Ports 2, nothing really changed there. Let's look at another one. Show ether channel summary, right? We got it down right here. But the status is still in use. It's still up. It's still functioning. Even in our topology, we see that this is down. This link is down. But that's a physical, right? Because we're looking at the physical topology. But logically, we see that this port channel logically to the switch is still showing everything as up. So I definitely wanted to show you that even though we took one of those ports out of the bundle, it's still showing. We would have to take both of them down for that port channel to go fully down, because it's just looking at it again at a logical thing. Let's look at that show ether channel. What was it? Protocol. What was that? Port dash channel. And again, look at the time that it changed. That thing came up differently, right? Because something happened to it. So it's only been up for a minute where we ran it before. Look at that. The age of it was really 8 minutes, but it's only been up for 1 minute. Well, we know why it's only been up for 1 minute, because we shut down one of them ports. So let's just go ahead and bring that port back up. And we no shut that boy. Let's look at that one again. Now 3 seconds, but again, 8 minutes. 3 seconds. You feel me? How you could use that, and now you see the difference. Now we got 2 ports that are up in the bundle. And that's just a way to verify. That's just a way that you can practice your verification skills of the port channel, right? So let's get out of this, jump back over to our topology real quick. Now we're going to just do a layer 3 ether channel. So we jump in this guy right here. Let's look at show spanning tree over here. Again, port is blocking. Look at the cost and all of that there. We got 2 physical ports, but we're going to bundle them. But instead, we're going to do this in the layer 3 ether channel. So to do that, we're going to go in here. Same command setup. FA. Oh, no, we're doing gig ports now, right? Gig 0/1 to 2. We still want to do the same stuff. We want to shut everything down. We don't want to switch it up, right? We want to stay with the same steps so that we get this stuff, so we get practice, you know, so we can get that practice down. Same thing. Let's go ahead and interface range is gig 0/1 and 2, right? And we're going to shut that guy. All right, now that we've changed this from a layer 2 port to a layer 3 port, let's go ahead and let's bundle these into a port channel. And then what we're going to do is we're going to configure that port channel with the IP address. And then we'll just test layer 3 connectivity over that over the layer 3 ether channel. So the same command, you're going to do channel dash group. What number are we going to use? Again, here to show you, we're just going to use number 2. This is second port channel or second ether channel. Same difference that we're going to be configuring. Mode, and then we're going to use the same command. Here, we'll do active on this side. It's creating it. Now we exit out of there, port channel 2. And now if we do IP address 172.12.1.4, because it's switch 4, 255.255.255.0. Now we have an IP address on our port channel. So let's swing over and let me show you that on the other switch right here. So again, all we did was put that channel group mode active command, and that brought up and created our port channel interface, port channel 2. And then you just IP address 172.12.1.3. And now we have a layer 3 ether channel. All right, now that we got everything configured, now let's go ahead and enable the ports, bring the port channel up. And then before we go to verify any of the ether channel stuff, the layer 3 ether channel, let's just verify ping connectivity, basic ping connectivity. So we're just going to go interface range, gig 0/1, 2, 2, right? No shut on this guy. Swing over to the other one. Right, we'll end this. Interface range, gig 0/1. And we'll no shut on that guy. Hit enter here. And hit enter here. All right, now that we have enabled both of those ports by doing no shut on our ether channel, let's go ahead and verify that with just a ping across. Let's see if we can make it across. 172.12.1.4. And we have ping connectivity right there. Let's look at our ether channel now. Show ether channel. Look at that, we got channel group 2, layer 3 for a layer 3 ether channel, port 2. Same commands we're using, right? Show ether channel summary. Just looks a little bit different. Here we go. LACP. This changed from S to R because it's layer 3 instead of layer 2, but it's still in use. And then also show ether channel, and then it was port channel, right? And look at that, it's been up for 1 minute, but it's really been up for 7 minutes. But I had to edit it out, you know, I was messing up on the lab, but you can still see the timestamps are still going to show you and reflect. This should show you that something happened, right? This port channel's been up for 7 minutes, but I had to bounce these ports to get it up because it's a lab and anything can happen. So if your port channel doesn't come up right away and you're verifying, just bounce them ports. When I say bounce the port, bounce these ports right here. And that should bring it back up, because it might not just come right up again because this is a lab and everything. So make sure you watch that when you try to do that. All right, I know that was kind of a long-winded one. Hopefully it made sense. Hopefully it helps somebody, and it gives you kind of like a step-by-step process to configure your ether channels and verify them. Mainly just make sure you shut down all them ports to try to avoid any kind of craziness because you're working in the lab, and then you don't even want that even in production. Make sure that you just shut it all down, configure them, then enable them, bring everything up, and then make sure that you verify it. And if you're using the layer 3 ether channel, make sure that you're pinging to make sure that that IP connectivity is there, because that's the whole point of the layer 3 ether channel. Hopefully you got some kind of value out of this video. If you did, definitely hit me with that like, definitely subscribe if you can. I appreciate, as always, each and every one of y'all. Make sure y'all turn on them notification bells, because you know I'm coming with another video with you next week. And also drop in the comments what y'all want to learn more about. If you don't want to learn about these labs, you want to learn more about the industry and stuff like that, or what's going on, how to get that money in there, just hit me and on the comments, or you know what I'm saying, hit me on email. Check out my about section. I got my email there. You can email me some requests or whatever, so we can connect and really get down. Again, appreciate each and every one of y'all. I'll tap in with y'all next week on that next video. Holla at me.